Test, 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 test. Good evening, ladies and gentlemen, and welcome to the September Recreational Astronomy Night for the Royal Astronomical Society of Canada Toronto Centre. My name is Tom Luton. I'll be your host for this evening. You're joining us live at York University. We are in the Petrie Science Building, just down the hall from the Alan Carswell Observatory. So, our show tonight, we have Andy Beaton with The Sky This Month, and then Arushi Nath will be joining us remotely, talking about building a remote observatory for planetary defense and exoplanet characterization. But before we get started with all that, we have a few awards to give out. So a few weeks ago, we had our open house and awards picnic at the Carr Astronomical Observatory. Not everyone could make it all the way up north, so we're giving out some of the awards right here, right now. Now, the first award is the Bertram J. Topham Award for Observing. We are presenting this to Frank Dempsey. Frank, however, was given this already passed along by a friend, so he's already gone ahead and had it framed. Frank, come on up. This award is in recognition of Frank's many observing projects that he's been doing currently and in the last few years. Frank?
Super, thank you.
Our next award is the Ostrander-Ramsey Award for Astronomical Writing, and this award goes to Nicole Mortellaro. Nicole is the author of a very successful series of astronomy guidebooks. Night Sky Almanac, a month-by-month guide to North America's skies from the Royal Astronomical Society of Canada. I just want to point this out that in 2024, the 2024 edition placed in the top 25 astronomy books on Amazon.ca. To put that into context, book number 25, she was 24th out of 25, but number 25 was written by some guy named Stephen Hawking. So we would like to award this to Nicole in recognition of her wonderful book and hope that you will be presenting us with many, many more. Now, the next award is the Burt Winnels Award, also known as the President's Award. This is a award, as the name suggests, selected by our president, Scott Masterton, who unfortunately could not be here tonight. And the winner of this year's Winnels Award is Dr. Elena Hyde, in recognition for the significant work that she did last year. As you may know, the Science Center was shut down with literally zero warning, and we found ourselves homeless. And it was thanks to Elena's hard work that we found a place that we are here speaking to you tonight. So Elena, on behalf of Scott and on behalf of the entire center, thank you. All right. Unfortunately, our fourth award winner seems to be running a little late. If he shows up at the end, we will give out his certificate. But let's get on then with Andy Beaton and The Sky This Month. Andy.
Hi there. My name's Andy Beaton. I do my observing from the exciting downtown location of Bathurst and Bloor. And I'm here to talk to you about what's coming up in the sky this month. Most of you have heard my talk before, so you know what's coming. The big picture, key dates, the sun, meteors. You see we're going close to far. Aurora, the moon, planets, asteroids, comets. I always like to talk about a double star, and it wouldn't be my talk without variable stars, because that's my thing. Something from the deep sky, whatever is coming up in space flight, and emergency planning just in case it gets cloudy. So starting with the big picture, tonight at 10, after astronomical twilight, if we look to the west, this is what we're going to see. Our favorite summer constellations are starting to trickle away. You may notice a complete and utter absence of interesting planets there. we've got the moon, and it's kind of a half moon, so it'd be an interesting one to look at. Lots of nice shadows on the craters and mountains. But if you're looking for your summer deep sky objects, the moon is just going to be a pain in the backside for that. By the time we get to the next meeting, for those of us who like to get up early in the morning and do our observing, now we've got some planets. We've got our favorite winter constellations coming up, Orion and Gemini and Taurus, all our favorite deep sky winter objects. The moon will be out of the way, and we've got lots of planets. We've got Venus just coming over the horizon. Saturn is actually off the screen there, but it'll be nice and high. Jupiter in Gemini is going to be unmistakable. That's one you're not going to miss. So important dates coming up. Since I know this presentation can be seen by people who are not just in this room or even just in this city, I'm mentioning that we have a total lunar eclipse coming up on the 7th. It is unfortunately only visible on the other side of the world. We don't get to see it, but hopefully somebody watching this broadcast gets to have a look and see the eclipse happening. On the 21st, we have a partial solar eclipse. Once again, it's not for us, it's for people in the South Pacific. I believe we've had people comment here from New Zealand and maybe Australia. So hopefully they'll get to see something. Obviously, if we've got an eclipse, we also have a new moon on the 21st. So deep sky observers, that's your key date. Also on the 21st, Saturn is at opposition. That means it's on the opposite side of the Earth from the sun. So it's going to be as close as it gets to us, and it's going to be nice and bright. Fall equinox is coming on September 22nd, and that's the point where our summer is officially over and fall starts. It's also the point where night is longer than day, which is, I guess, good for us, isn't it? As the nights do get longer, twilight is ending at 9:20 tonight and starting again at 4:40 in the morning. By the time we get to October 1st, twilight will end at 8:20 and start at 5:25 in the morning. So we've got a much longer dark night for those of you going to be doing your long-term, long exposure astrophotography. The sun is very active right now. I was just talking to someone in this room saying that we had aurora happening over the past few days. I didn't see any. Mostly what I've seen about it is people on social media saying, I didn't see it either, but keep an eye out for it. It may come along anytime. You never know with aurora. So meteors, it's a lousy time for meteors. We don't get any major meteor showers. The last of the Perseids are gone. We're not getting anything else until well into October, but we do get some minor meteor showers coming up. The September Epsilon Perseids and the October Arietids, though they're minor showers, at their peak, you're getting less than 10 meteors an hour. I wouldn't get out of bed and rush out to the dark skies to have a look for any of these, but if you are out observing and you see a meteor, you can trace back the direction it's flying in the sky and see if it heads towards the star Epsilon Perseus or to the constellation Aries. You may be spotting one of these minor meteors. We also have meteor dribbles, something not even a shower, less than 2 meteors an hour. The September Lynchids and the Chi Cygnids, I don't know why we even bother pointing them out, except that I don't have any good meteor showers to bring you, so bring you some bad ones. This is something I dug up recently while researching my presentations, is that you can do some meteor chemistry. You can tell what the meteors are composed of by the colors that they glow as they burn up. Obviously, this is just for bright ones. The dim ones, they just look white. There's not enough light to set off the color receptors in your eyes. But the bright fireballs, if they're yellow, they are containing iron. Orange yellow is sodium. Violet's calcium, and magnesium is a blue-green color. I've only ever seen orange yellow that I can be consciously aware of. I'm sure I might have seen others that I'm just not remembering. Green and red are different because that's not the meteor chemistry you're looking at. That's the atmosphere. Green is for oxygen in the atmosphere being excited, and red is for nitrogen. We get that a lot with slow meteors. So there's a science project for you if you're ever out meteor watching and see something good. So aurora, as I was saying, the sun's active. We are getting aurora being observed just the past few days. It may be still happening. I was doing some solar observing last week, and there were fantastic, huge prominences. So the sun is in an active time. So we never know what's going to be happening. The northern horizon, looking for a pale glow, that's probably what you're going to spot first. My experience is it just looks like city glow, but if you take a picture with any modern smartphone and you find that the glow is actually glowing green, then you've got aurora, because that's not the natural color of city light. The place you can check to see what's happening with the sky is spaceweather.com. That's where I go to see when I should be expecting aurora and to hear what other people are observing. So we've got the moon, full moon on the 7th, new moon on the 21st. I'd like to point out September 10th and September 26th, we have perigee and apogee. That's when, nuts. There's my first typo of the presentation. Perigee is close, apogee is far. What we want to do is take images of the moon at those two different dates and compare the size of the images. You can see that when the moon is farther away, it's noticeably smaller. And there's evidence that you can gather yourself that the moon is in an elliptical orbit. I like these little science projects that you can do yourself. The lunar X is visible on September 29th. What the lunar X is two craters side by side. And when the sun is illuminating the crater rims at just the right angle, it looks like a lit up X against the black shadow on the moon. Scientifically, it means nothing, but it's neat. And it looks fun, and it's an interesting way to drag yourself out on a cold night to go and look at the moon, which is always worth looking at. Straight wall is another lunar feature that's worth looking at. It's on the evening of September 30th. It's a long, straight rill on the moon's surface. When the angle's right, it shows up as a brilliant shadow. And it looks neat because you don't really see straight lines in nature very often. This is one of them. Now, the really interesting thing coming up on September 8th or 9th, I don't know who knows their orbital mechanics terribly well, but the moon wobbles back and forth as it orbits the Earth. A process called libration is wobbling back and forth. When it wobbles this way, we can see a feature on the far side of the moon, Mare Orientale. It's a lunar sea, which is just on the around the corner. When it wobbles the right way and the sun is illuminating the moon from the right angle, you can actually see this far side of the moon feature. It was only identified a few decades ago, so you're seeing stuff that astronomers missed for centuries. So yeah, put that one on your observing project list. So planets, starting with the rocky planets, Mercury is hopeless, forget it. On the other hand, Venus is bright and visible in the morning sky. If you're going to look for it as soon as possible, because as the month progresses, it's sinking lower and lower into the morning sky as it's getting ready to pass around the back end of the sun. Mars is visible in the evening, sort of. It sets before twilight is over, but it's really too far away to see any interesting detail on it. The sky is going to be too bright. So unless you have a weird obsession about seeing Mars under any and all circumstances, that's one I wouldn't bother with. Now, the gas giants are the planets that everybody loves. Jupiter is the bright one this time, but you need to wait until 2:45 in the morning for it to rise. And it's a -2.5 magnitude. It's insanely bright. You're not going to miss it. It will be so obvious that everybody's going to point and say, yeah, there it is. This month, there are multiple double shadow transits. What this means is moons of Jupiter orbiting around it are causing eclipses onto the surface of Jupiter and casting shadows. And every now and then, you can see the shadow as it transits across the surface of Jupiter, and it looks neat. It doesn't take much of a telescope to say, okay, here's a black spot that you can see. That's a shadow crossing the surface, but every now and then you get two of them at once. And the geometry at this time is such that we're getting a bunch of them happening over the next few months, several in this month. The RASC handbook is your best place to find these listings, or your planetarium software. Set it up to look at Jupiter and hit play and let it run until you see the interesting shadows that you want to look for. I'm guessing everybody with a telescope has seen the 4 big moons of Jupiter. If you have a bigger telescope, and I know some of the people who are going to be listening to this will, try for some of the smaller moons, like the Amalfi and Himalaya, down in the 12th and 13th magnitude range. I know that there are a lot of advanced observers in our club here, and I want to make sure they have something to look forward to as well. So Saturn is up all night. That's going to be the showpiece for all the star parties for the next few months. It's bright, not as bright as Jupiter, but still pretty noticeable. Unfortunately, the rings are very close to edge on. It doesn't look as cool as it does as when the rings are wide open. On the upside, when the rings are close to edge on, you can find the moons a lot easier because you're getting a lot less glare outside the disk of the planet. I was doing some observing a couple of weeks and got a couple of moons down in the 12th and 13th magnitude range, something that I could not do when the rings are at full brightness. Titan is an obvious moon, but there are 7 moons brighter than 13th magnitude, according to the Observer's Handbook. So some of those should be reachable with most telescopes. Then we get to the boring planets, the ice giants, Uranus and Neptune. They're not boring, they're interesting, but they're not really exciting to look at. Uranus is brighter than 6 magnitude, easy to find with binoculars, not very big, 4 arc seconds or less. But some large telescopes, you may be able to get some of its moons as well. And I'm going to draw your attention to a scientific question that has bugged me a long time, which is whether or not it is blue or is it green, and how does it compare to Neptune? Last time I was looking, I thought Uranus was blue and Neptune was greener, but other times I'm never really sure. Anyway, take a look yourself and see what you think. Neptune is also up all night, rises around 9:30, and it's pretty close to Saturn. So if you have a wide-angle camera, you might get an interesting image with both planets. It's not very big, but Moon Triton is findable. I think it's something in the range of 13th and a half magnitude. Could be done with an 8-inch telescope under good conditions, but you'd want something bigger than that if you want to be certain. So the dwarf planets, we've got two of them that we can see. I mean, there's a bunch that we could maybe image with a giant telescope, but I don't think that's me, and it's probably not you. But Pluto is achievable. It's in Capricornus, just over the border from Sagittarius, 14 and a half magnitude. I saw it 15 years ago when it was brighter than 14th, and it was a hard slog on an 8-inch telescope. I'd say you probably want something 12 inches or better if you're going to try for it this time. It's tough visually because there are so many dim stars around there. It's really difficult to get a certain identification. Best method is imaging. Get a bunch of images and compare them night to night, week to week, and look for that one that moves. Same way it was actually discovered. Ceres is the other minor planet that's a dwarf planet that's visible. It's in Cetus, 7th magnitude. It will be an interesting project because it'll move quickly. It moves about 5 arc minutes from night to night. So mapping it from night to night, week to week would be an interesting project. When I was in university, we were actually given the project of measuring and calculating the orbit for it. That's a lot of math. Some of you might want to do it. I imagine most won't, but you can at least consider it a possibility. Or make your kids do it. That'll be a good math project for them. Since Ceres is no longer an asteroid, I'll draw your attention to other asteroids. There are a few asteroids visible brighter than 9th magnitude tonight. Pallas, Julia, and Hebe. There are dozens and hundreds and thousands more as we get to dimmer and dimmer magnitudes. Whenever I go out observing, I always like to see something I have never seen before. And if you're observing in the city, galaxies and nebula are right out, but finding an asteroid that I'd never seen before is actually a pretty manageable task. Dig through your planetarium software, check out the area of the sky you're going to, find a likely looking asteroid, mark it on a map, and go looking for it. It can be done. Comets, it's a lousy month for comets too, or at least it was when I was checking earlier on. C2025 K1 Atlas at 12th magnitude. It's not an interesting comet. Even with a large telescope, a small fuzzy blob is the best you're going to get. There's going to be no spectacular tail or anything that is going to impress people. If you've never seen a comet, yeah, I guess look for it. It would be exciting. But actually, no, if you've never seen a comet, wait till a better one comes along. You'll just be disappointed. If you're a real comet lover, though, there's a few 15th magnitude comets, 217P linear, C2021 G2 Atlas, and 240P neat. That's probably as good as you're going to get. hopefully we'll get some better comments coming up. My late friend Blake Nancaro got me hooked on observing double stars, and this one is an interesting one, I guess. I'll tell you why. It's a fairly bright pair, fairly wide, far apart. Just about any telescope is going to be able to split them. The Observer's Handbook rates a bunch of them by their aesthetic value. It gets 1 exclamation mark out of a maximum of 3 for beauty. So it's nice. It looks pretty. Now, here's the thing. The Observer's Handbook describes the pair as yellow and red. So when I was researching this, I went and looked, and they looked white and blue to me. So here's another science experiment for you. Go out and look at Capua Herculis, and do me a favor, note the colors that you think you're seeing, and send me an email, because I'm curious to see what other people are observing here. I mean, I don't want to say the Observer's Handbook is wrong, but I don't want to say that I'm wrong either. So it's an open question there. I'm curious to see what who you think is wrong. So here we are. Here, there's a little map of it. Corona Borealis and Hercules there. And down near the bottom corner of Hercules is where Capua Herculis is. So not too hard to find, fairly bright. So there's yet another observing project for you. Now, because it's me doing the presentation, you're getting a variable star, whether you like it or not. Z Andromedae is the one I picked this time. It is what is known as a symbiotic variable star. It's a class of cataclysmic variables. Goes from 7.7 to 11.3 magnitude. And what we have is a white dwarf and a red giant orbiting around each other. The extended atmosphere of the red giant is very tenuous, and the more intense gravity of the white dwarf is slurping up material from the atmosphere of the red giant. And as it accumulates on the surface of the red dwarf, when enough accumulates, it will ignite a brand new burst of fusion. Now, these ones are interesting because they are fast and not entirely predictable, which means they are not going to be easily caught by all the automated sky surveys. The Vera Rubin telescope does a complete sky every 3 days. A variable star like a Z Andromedae type will ignite over a course of a few hours. Now, astronomers who are interested in these things don't have time to sit in front of a telescope for weeks or years on end. Here, let me just jump ahead for a second. Here is the light curve for Z Andromedae. This is over 10 years. So if we take a look, 8 years ago, there was an outburst up to 9th magnitude. And it went up fast there. Now, if I were a professional astronomer observing variable star, I'm not going to sit in front of a telescope checking Z Andromedae every hour for 10 years. This is the kind of stuff that can be handled by astronomers, amateur astronomers like us. You know, there's lots of us. Many of us are looking for a real scientific project to work on. We can go out, it takes us 20 minutes to make a measurement here. We can probably do 10 or 20 stars in a night. And that data is waiting there for professional astronomers when they need to do their calculations, do their studies with all that data. So this is a way for another way for us amateurs to actually contribute to real science. Now, the other variable star, T Corona Borealis. What the heck is going on? I stood up here a year ago and I said, this star is going to ignite, it's going to be spectacular. And a year later, nobody knows why it hasn't gone up. Normally 10th magnitude goes up to 2nd magnitude. Here here's a little map of Corona Borealis with T Corona Borealis down in the corner. It's going to be super obvious. It's an easy constellation to spot, and it's going to be the brightest star in the constellation. So it will be easy to see. The only question is, why aren't we seeing it? At this point, I think the question of why we aren't seeing it is almost more interesting than why we would be seeing it if it did go off. So anyway, astronomers around the world eagerly awaiting this outburst. Maybe you could be the first to spot it. So I always like to point out a few things in the deep sky that people can add to their observing project list. I've gone for M8, the Lagoon Nebula, and there it is, according to the ESO Parnell Observatory. It's not going to look like that to you and I, but it's a rough thing. But I want to point out a few things. One is the black stripe going right through the middle, and the other is the little black blobs throughout it. So it's a nice bright nebula. It's so bright and contains bright stars, makes an excellent target for beginning astrophotographers. And the reason I say that is when I was trying out astrophotography, getting a good focus on a nebula was very difficult to me because it looks like a gray blob even when it's in focus. This one has nice bright stars, so that'll be nice and easy. If you're an experienced imager, gas tendrils connect it to the Trifid Nebula. That's going to be really deep sky stuff. You're not going to get that from downtown Toronto. But if you're viewing it through an O3 filter or some other similar sky filter, then you can cut down the glare from the stars, you can blacken the sky and see a lot more detail than you would expect for just the naked eye. Area known as the hourglass in the brightest part of the nebula is worth seeing. And those little black blobs I was pointing out are Bok globules. And what those are stars that are forming that have not yet brightened to the point where they're shining. They're just black blobs of contracting gas and dust. I've never seen one through the telescope. If I had a much larger telescope or a photographer, then maybe I could do it. And for astronomers who are just in their early stages, it's part of the Messier certificate. What we have here is 110 objects recorded by Charles Messier back in the 18th century, reminding himself which blobs in the sky were not comets. But among those, a lot of interesting things: star clusters, nebula, galaxies, all things that everybody should see at least once. Seeing the entire Messier catalog, it's a good grounding for what you're going to be able to find in the night sky. And you can get a certificate for it and put it on your wall and show it off to your friends and family. So if you're looking for M8, there we go. There's the teapot in Sagittarius. And there's M8 bubbling up in the cloud of steam that's the Milky Way. Now that's very nice for the astronomers just getting started here. If you're looking for something more challenging, the Veil Nebula is one I was looking at a few days ago. It says the brightest supernova remnant in the summer sky, and that's I guess you would have to argue that the Crab Nebula is in the autumn sky because that should have been the second brightest. It's about 20,000 years old, so it's really spread out and really, really dim. But if you can see it with a largest telescope, maybe an O3 filter to help, it is quite spectacular. You see all kinds of lacy structure and tendrils and bands all wound together. It's quite beautiful. And I was reading that the Hubble Space Telescope has measured changes in the Veil Nebula over a space of 18 years. And I know there are people who are very serious about astrophotography who are getting remarkable images. And I'm wondering, how long it would take an amateur with an amateur scope to be able to detect any kind of change. I would say younger astronomers, get at it now, and hopefully when you're an old astronomer, you'll be able to detect that change. Now, for really serious people who are looking for something they've never seen before, this is beyond the Milky Way. It's a Mayall 2, and what it is a globular cluster orbiting the Andromeda Galaxy. It's just brighter than 14th magnitude. It's 130,000 light years from the center of M31. See, there it is. There's M31, and there's Mayall 2 down in the corner of the image. So it's a good distance away. You'll want a really good star map or planetarium software to find it. But it's the brightest of 500 globular clusters that have been identified around M31. I have seen it in an 8-inch telescope under superb conditions. And the good news is it really looks like a stellar object from here. It's so far away and small. And stellar objects or things like it are the best things for getting through light pollution. So it's probably going to be very difficult from the city, but outside the city, even with a certain amount of Toronto sky glow, it should be reachable. And that's got to be a cool thing, seeing a globular cluster around another galaxy. So spaceflight, we've got a few things happening. Cygnus spacecraft is going up to resupply the ISS on September 15th. The Interstellar Mapping and Acceleration Probe, or IMAP, is launching on September 23rd. Escape and Plasma Acceleration Dynamics Explorer, September 29th. Now, I was watching on the weekend for a company called Nord Space to launch a rocket from a Canadian launch facility in Newfoundland. It was canceled on the day I was watching it. I don't know if they have launched yet. Have they launched yet?
They have not launched yet, but the CEO told me that it was sometime in September. They just need approval to get through the government.
Okay, for those who are not able to hear that out on the internet, apparently they are waiting for government approval for their next upcoming launch attempt sometime in September. And we also have the ISS. It'll be passing over early in the morning until September 7th. And after that, there'll be evening passes until the next meeting. I can't give exact times because it varies so heavily with where you are. So go to heavensabove.com for exact times for your own personal location. Now, if you'd been to the CNE and you lost your glasses on the Crazy Mouse and you're looking for astronomical projects, Galaxy Zoo, zooniverse.org, has dozens of astronomy-related citizen science projects. A few of them that I picked out for this month. Rubin comet catchers, that's data from the Vera Rubin Observatory looking for comets. Cosmic collisions between galaxies, Einstein at home pulsar seekers, and active asteroids. Are they asteroids or are they comets? That's up to you to decide. So we know it's going to be cloudy sometime. There we go. We've got some astronomical projects that we can work on. So if you have any questions, feel free to email me, andybeaton@gmail.com. I'm on Blue Sky or on the RASC Toronto Centre Forum. Thank you very much.
Thank you very much, Andy. Questions from the audience? No questions? Oh, wait, question from Frank.
Not a question, but a comment. So it's worthwhile to point out because some people will find it interesting. This is a year for some rare instance of passage of Titan's shadow across Saturn's disk every 2 weeks, every 16 days actually, a few times this year. So one is coming up tomorrow morning, basically about 6 hours from now. It's irrelevant for Toronto area because it'll be raining or pretty darn cloudy. But it might be some people online who might be interested to know that that's a rare sight to see, and there's been a few already this year, and there'll be maybe 2 more until October. So one of them is tomorrow morning. So it's just wanted to mention that.
I have never seen a transit of Titan shadow across Saturn, so thanks very much, Frank. I appreciate that.
Yeah. So just so anybody knows, I need a very clear view of Saturn, and the Titan is a tiny dot, of course, and the black dot of its shadow is visible under good atmospheric conditions. Not hazy or cloudy like tomorrow morning, but very clear sky. And I've seen a couple, and they're pretty distinct and pretty rare to see. So in case anybody online has a chance to see it tomorrow morning, it's worthwhile to mention. Very rare event tomorrow morning.
Cool.
Okay.
Thank you.
Anything else from the audience? No. Any questions from online?
Not that I'm aware, but I'm having trouble doing that.
Okay, then. We're going to go to fun facts as we get ready for our next presenter. Before we do that, Andy, thank you very much. And our final certificate awardee has arrived. So, Andy.
Yeah, I'll get out of the way here.
So last but not least, definitely not least, is our Jesse Ketchum Award. They will decide to come out of the envelope. The Jesse Ketchum Award is for astronomical equipment, and this year the winner is Clayton Davies. Clayton in 2024 entered his homemade 10-inch f6 Dobsonian at Stellarthane in Vermont, where he won first place in both the mechanical design and craftsmanship categories. And well, who are we to argue with Stellarthane? So Clayton, congratulations, and
Thank you. Thank you very much.
all right. And so now we're going to go to fun facts and then get ready for our next speaker.
Today I'll be taking you on a journey of first how I started my interest in astronomy and how eventually I created my own remote observatory. So, a bit of story. It started on July 25th in 2014. So this is like 11 years ago now. And it's a night that would change the way I looked at the sky completely. It was the first time I went to the Carr Astronomical Observatory. I remember going there, I was really small, I was like 4 or 5 years old, And I remember at night being able to look through this huge telescope and see Saturn, a big blob with rings around it. And I got really fascinated and I started sketching it and observed many more objects later that night. But it's really that moment that made me think I want to keep doing this. I want to see more cool objects like this. And it started my next 10-year journey where I started creating my own projects in astronomy. I would learn new skills, observe new objects, and try to fiddle around with all of the stuff that I knew and create projects related to astronomy. And I developed an interest in photometry, so measuring the precise change in brightness of an object over time. And I use this to develop algorithms in Python, where I was looking at the photometry of asteroids, exoplanets, and I was able to use this to provide citizen science support to NASA's DART mission and the Ariel mission. And I also believe in teaching others. So every time I would build a project, I would be able to talk to it at different organizations like RASC and be able to share my project to youth, adults, families, and everyone. And I started entering my projects into different competitions, internationally, nationally, and being able to, for example, win the top award at the Canada-wide Science Fair and present my project at a space conference in Vienna. And each time as I create a project, they grew more and more ambitious. And suddenly I realized I didn't have enough resources of my own to keep building these projects. So that's when I started reaching out externally, writing proposals to different organizations to get a few hours of time on their huge space telescopes to be able to get lots of photometry observations for my asteroids or exoplanet targets. But oh, sorry. Can you see them now? Are they full screen now? Oh, that's strange. Let me see what I can do. Perhaps here. Perfect. Great. Absolutely. Yeah. Okay, so this was my first slide and going on. Yep. So first time I was able to look through the sky at a telescope at the Kerr Astronomical Observatory. I was able to view Saturn, sketch it, and it really created my interest in astronomy. And I started creating my own projects. You can see the slides right here. And jumping up, so as my projects grew more ambitious, I didn't have enough resources to do it myself, which is when I started reaching out different organizations, getting time under telescope by writing research proposals. But suddenly I realized that these few hours on big telescopes weren't enough for my projects. I needed a long baseline to observe exoplanet transits, binary asteroid eclipses, and I realized there was only one solution left because living in Toronto, we have terrible light pollution. There's no way I could observe any of these targets on my own. So the solution was to be able to build my own remote observatory in a dark sky location. And for this, I would like to give a huge thank you to the Mastodon Foundation. It's an organization that supports the next generation of kids, youth interested in science by giving them the funding, resources, and tools that they need to be able to turn their dreams into reality. And as a 15-year-old student, I would never have thought that I would be able to, at this age, create my own telescope. So a big thanks to them. Um, so a bit of history. Last year in 2024, I was selected as one of the 25 youth as part of the Mastodon Foundation. And through there, I was able to share all of my research on asteroid and exoplanet research to Masayoshi-san, who and the Mastodon board members. And from there, I was able to acquire funding, basically, to get my project to the next step and create this remote observatory. So it's been a year-long journey. I'll get into more details right after, but a few quick facts. I just slapped my 12-inch RC telescope in Spain. And basically the main goal of this telescope is to be able to perform very accurate millimag photometry on asteroid and exoplanet targets. So first, why Spain? So in Spain, in Nerpio, there is this organization called Astrocamp, and they have this huge telescope facility. So they have a dome, they have internet connection, and they're able to keep telescopes inside to observe the night sky. And one of the best parts about this observatory is that it's very dark night skies. As you can see from this light pollution map, it's very far from any light pollution from surrounding cities. Also, it's on a mountain, um, about 1.5 kilometers high, or sorry, 1600 meters. So that means it's above lots of clouds, not much rainfall, and perfect conditions for night sky observing. And in fact, it has almost 300 clear nights a year. In addition, since this was a facility, it had an on-site technical team. So in case I needed extra support, an equipment was not working, I'd be able to get assistance right away. And also it had an automated roof controlled by a weather system, meaning I'd be able to get the most amount of imaging time possible while not compromising on any instrument quality in case of bad weather conditions. And it also had electricity and internet connection, which is everything I would need. And actually, one of the best parts is since it was in Spain, it's 6 hours ahead of us, which meant that 4 p.m., 5 p.m., when I came home from school, it would already be nighttime in this observatory, and I would be able to set my observations up without staying up late at night, which was amazing. So equipment. So this was a really challenging part. I want to select equipment that would allow me to get the most precise photometry possible. So these are a few major pieces of equipment I chose. For telescope, I chose a 12-inch RC telescope. And I chose RC because it was able to minimize aberrations like comma. And I chose 12-inch. It was a very nice, big size telescope, which would allow me to capture even the faintest objects at a high signal to noise ratio. For the mount, I chose the EQR Pro SyncScan. It had a huge payload capacity, enough to be able to support my telescope and all the cameras and imaging equipment I would need. For the camera, I chose the ASI 2600. It had a huge sensor, which meant I would be able to have a lot of precision. And it had also a cooling system, which meant I would be able to cool my camera to reduce any noise. For the microprocessor, I chose the Eagle. And I chose it because it can not only control my equipment, but it can also power it, which meant I would not need a separate power box. Filters, I chose all of the UBRI. This would allow me to observe my targets in many different filters. And for guiding, I decided to go with the off-axis guider. And the reason for this is because unlike when you have your separate guide scope and guide camera, with an off-axis guider, it takes the same light as your imaging train, which improves the precision of the guiding. And finally, for the focuser, this was an important part because since it's a remote telescope, I can't go there in person and slightly tweak the manual focus till my camera reaches focus, which meant I needed to have some electronic device to do so. So that's what this focuser does. So for my equipment selection, I chose the vendor Balconic. It was very close to my observatory site. It was in Spain, which meant no import fees, no shipping fees. It was right next door, which also meant if any parts were broken, not working properly, it would be really easy to just ship them back and get them replaced. Also, it had all of the equipment I needed in stock, which was really important, and the price was reasonable with discounts offered. So the physical assembly of the telescopes, so this started about mid-March when all the equipment started coming into the facility. So I hosted all of my equipment onto a pier since this would be a permanent observatory location. So I was able to put my mount on and then attach the telescope tube. Actually, midway through this assembly, we realized there wasn't enough counterweight, which is why you can see in the second image, a third counterweight is added. And then finally attaching all of the optical train, the images, the camera, the filters, the off-axis guider to set my whole equipment up. And right after that was telescope collimation, and this is really important. This is when I'm aligning my mirrors together so I can create basically sharp stars and make sure all objects come into focus. So we used laser for this alignment, and we were able to point it, and you can see the second picture, all the laser rings are overlapped, and it all converges at a single focal point right here. So in about beginning April, I had my whole telescope setup complete. You can see in the picture here, all the camera, filters, mount, everything is attached properly, and was balanced. And you can also see that there's, in the second picture, there is other telescopes around, because since this was a facility, there's many other also amateur astronomers hosting their equipment to be able to observe their own targets, whether it's astrophotography, maybe even exoplanet observations. So it was really great to see all of the equipment together. And one of my favorite parts was actually I was able to view my telescope through a webcam because I had a webcam attached right below my telescope. So this meant during the installation process, while I was helping them install it, I was able to see everything remotely. And it's also cool once I started getting my observations and I could see how the telescope was slewing every night. And addition, because of this camera, I'm able to see every morning, every night as the telescope dome opens and closes, like you can see right here. This would have been morning time, right after dawn. The next step was polar alignment, and this is really important. It's basically the process of aligning my mount so that with the north celestial pole, which means I would be able to track the objects effectively across the night. And I had two attempts of this. The first time, we had done about a 10-star model, and we were able to get about 1 to 2 arc-minute precision level. So this was great for a first attempt. I was able to take short 5 to 10 second exposures without any problems. But I noticed that after it started getting longer, like a minute exposure, I noticed a lot of trailing of stars in my images, as you can see here. So we did a second attempt with this, and we were able to do a 30-star model, and from there get a very precise guiding, polar alignment up to a few arc seconds. And from here, you can see this is actually a 3-minute exposure, and you can see there's barely any trailing within the image. So this is actually the current polar alignment model that I'm using. And with polar alignment, next step is star alignment. And this is basically telling my telescope where it needs to slew. So how I did this is I used GS server, and I selected about 10 reference stars situated all across the sky. And I chose these stars using Cactus Ciel, the software. And from there, I was able to slew to each object manually, and then or through the telescope, and then manually adjust it till the object was in the center of the field, and repeat this for all 10 objects. One thing I did notice at the start is because the pointing model was so off, it wasn't even coming in my field of view. So I had to plate solve my image and be able to find where exactly my telescope was pointed to and then do it like that. So it was a huge learning experience. They're definitely very different from aligning a telescope in person physically. So first light, once I had my polar alignment and star alignment done, I could finally point it at an object. So this was about mid-June, eventually when all my equipment was set up and running properly. So my first target was the M16 Nebula. I was able to take a 3-minute exposure, and as you can see here, the object came clearly. There's no trailing anywhere, and I was able to test out my equipment this way. At the same time, I was also testing out my camera cooling capabilities. And cooling is really important because I was able to get my telescope to about 35 degrees below ambient temperature, which allows it to reduce a lot of hot pixels and noise across my observations. So calibration frames, this is again used to reduce noise. So there's 3 different types of calibration frames. You might already be aware of them. First is bias frames. So these are taken at close to 0 exposure. And these are meant to measure basically the readout noise. So what difference is between the light that's actually on the pixels and what the camera is reading out from that. So I took about 60 of those. Second is dark frames, and these are really important. I took these at the same exposure time as any of my science images would be, and same filter. And this is meant to remove any hot pixels or thermal noise that might come up. Since my camera did have cooling, that was able to reduce the noise a bit, but using these dark frames improved it a lot more. And finally is flat frames. So this is meant to correct for vignetting, or dust or dirt on each sensor. And these frames I took after every observation night to be able to get the best possible, because sometimes dust may change, specks might come on. So it's always best practice to take them every night. So I was able to take these. And altogether, I was able to apply them to an image of the sky. For example, here you can see the raw image right before. So you can see there's a bunch of bright pixels. Stars are visible, but you can also see the background is also very bright. However, after I was able to apply my bias darks and flats, you can see that all of those hot pixels in the background are removed. And this means that all of my objects, stars, asteroids will stand out much more brightly. Um, Finally is the focusing my camera. And this is really important because I had mentioned before, I'm not there to be able to turn the knob, see when it reaches focus. So I had an automatic focuser, and I was able to test different focus points with it and see basically how sharp the star was using this curve here. So you can see right here is about the peak focus level. And you can see, for example, two examples of one is an unfocused star before I had done any focusing. And you can see there's like double lines and on this bright star and some faint stars around, you can see they're completely out of focus. However, after focusing these stars, you can see these lines appear much more visible. So creating a remote telescope was a completely different experience. I learned a lot, and there were many challenges. For example, I remember near the start when I was just getting my equipment settled, taking my first few observations and testing out everything, I noticed my guiding didn't seem to be working at all. Whenever I tried to select a star and guide on it, it wouldn't be able to guide properly. It kept going, star kept moving around, and I did a lot of checks. I tried calibrating my guide camera, guide equipment, verifying the polar alignment, looking through the webcam, trying to see if I can spot anything, and I didn't really find a problem. But eventually, we found out that the problem was simply due to a loose screw in the equipment, causing everything to shake a little bit, which is why my guiding wasn't coming correctly. And it was really interesting to learn that because such a small physical issue that if I was in person, I'd be able to see immediately. Since I'm online, it turned into a really huge problem. So once I had my equipment settled, the next step was getting an MPC code so that I could start submitting observations. So to do so, to get the MPC code, there's a few steps you need to follow. First, select about 10 or more near asteroids that you can observe. They need to be fainter than 16 magnitude, and it's a nice practice to make sure that they're visible from your side. They'll be visible for the next few days, and because you need to collect at least 2 nights of observations per asteroid. So, and each observation should have at least 3 to 5 astrometry measurements and 1 magnitude measurement. So once I collected this, I collected it over maybe 4 or 5 nights, and I was able to submit this data to the Minor Planet Center. And actually, just yesterday, on September 2nd, I got my observatory code R60. So over the past month or so that my telescope has been operational, I've been getting some preliminary observations of exoplanets. For example, here you can see the transit curves of 3 different exoplanets, Kel 12, WASP 59, and Kel 16. And all of these I had observed, so pointed my telescope to those objects for 4, 5, 6 hours to be able to observe the full transit. And I was actually able to publish them in the European Space Agency's ExoClock project, which was pretty cool. In addition, I've also started observing asteroids. Here you can see a compilation of about 6-7 light curves collected over a week span in late August. And you can see I was able to get about a few hours of observations of the asteroid 2977 over several nights. And from there, I was able to stack them up and get the rotation period of the asteroid. So all of this is just the start. I was able to submit my observations to AlcDef. And now that I have my telescope running, I'm really looking forward to being able to pursue my interest in exoplanets and asteroid photometry. So with that, thank you really much. I hope you enjoyed my presentation, and I'll be happy to take any questions. I cannot hear anything. Okay, sure. Nope.
Arushi, can you hear me?
Yeah, I can hear you now.
Okay.
Arushi, I'm just so impressed by what you've accomplished, particularly these past few months. Just everything from getting the funding to all the technical issues you've overcome, and your progress is just astounding. I'm just super impressed. Great on you.
Thank you so much. Thank you.
Anything else from the audience? No? Oh, okay.
Just for fun, what kind of flat field lamp do you use?
Oh, that's a great question. Actually, I'm looking directly at the sky. So either right before my observations, right near sunset, once the sun has reached a few degrees below, I'll put my telescope at the sky and be able to capture light. And from there, get my flat images. I found it's much better than using a flat screen, at least for my purposes, because since I have such a huge telescope, being able to align it with a flat field on the observatory site was a big hassle. And actually, through the sky, I've been able to get some amazing flat images.
Okay. Oh, one more.
I hope you don't think I sound obsessed here, but have you considered observing rapidly evolving variable stars with this setup, which it seems perfect for it?
That's a great question. And maybe, yeah, definitely that could be an option. Right now I'm focused on a few asteroid and exoplanet targets, but definitely variable stars could be in consideration, especially because those also require long-term observations, which my setup would be perfect for. And definitely, if you have any targets in mind that you think are interesting, please let me know.
All right. Seeing no other hands. Oh.
Okay, we have some comments and questions here from online. Adrian, let's see, Adrian Aberdeen was the first one. So cool. I love this Astro setup. Lewis Rifkin asked, how often do the technical staff check on the equipment, example, cleaning or things like that?
Yeah, that's a great question. Thank you for the comments. So the technical staff, they check on the equipment about once every month for normal technical issues. But if I have any issues that I see right away, like I'm not able to guide properly or through the webcam I see something's wrong, then they're available the next day to look at any issues.
Great. Let's see. Which Adrian Aberdeen wants to know, which image capture software do you use?
That's a great question. And right now, everything I'm doing through Nina. It's an amazing software. I'm able to control my guiding, my mount, my camera, all throughout the same software. So Nina it is.
Excellent. Adrian Aberdeen also wants to know, do you split your imaging time between exoplanet and nebulae, etc., or mainly exoplanets?
Absolutely. So my observatory is basically optimized for precise measurements in brightness of objects, so more on photometry side, which is why I've been concentrating on exoplanet and asteroid targets. If I want to go over to imaging nebulas like astrophotography, I would require a completely different set of filters, which is optimized for those. So right now, mostly exoplanets and asteroids.
Awesome. Okay, that's great. Adrian is still drooling over your setup. That's awesome. Thank you so much.
Thank you so much.
All right. So that concludes our speakers for the evening. We're going to have a quick break to fun facts while we set up for the announcements.
Thank you so much. Thank you. You too. Bye-bye.
1, 2, 1, 2. All right, ladies and gentlemen, so let's get on with the announcements for the evening. So, those of you out there, I'd like to welcome you very much to to joining us this evening. We've got two types of meetings here online on YouTube. Our Recreational Astronomy Nights, which you've just witnessed, and they're both online and in person here at York University. And then coming up in 2 weeks is the first of this season's Speakers Nights. For those of you joining us live via the YouTube chat, please ask some questions. Other people have been doing, make some comments. If you are a new member, please introduce yourself and let us know where you're coming from. So our next speakers night is in 2 weeks, September 17th, 7:30 p.m. online only. Dr. Jennifer Andrews, the associate astronomer from NORLAB Gemini North, will be talking about supernova forensic files. Massive stars at least 8 to 10 times larger than our sun, and their lives in some of the brightest explosions in the universe. While the supernova signals the death of the star, we can use the observations of the supernova evolution and its interaction with the surrounding material as a type of forensic investigation into the last moments of the star's life. And then coming up, our next recreational astronomy night is October 1st. Again, here, York University, Petrie Science Building, room 317, just down the hall from the Alan I. Carswell Observatory. Sky this month will be done by Claudio Oriani. Chris Vaughn will be giving a talk. The exact title is still to be announced. And we have one available slot to present. So if anyone out there would like to say anything or present anything, somebody is buying. And we've got one empty slot available. So if anyone would like to present something, just please let me know. And then, Elena, do we have the telescopes? All right, the telescopes have been set up. They are on the third floor of the Petrie Science, across the road in the, oh no, they're, sorry. Tonight we're observing from the Carswell Observatory itself with observatory tours. Oh, doors open right now, right after the meeting. So for those of you here, if you're interested, just head straight down the hallway. And also during the warmer months, sometimes, but not tonight because of the weather, we have telescopes set up on the Arboretum parking garage. So yeah, there's another reason to come down and join us in person. All right, so events coming up in the Toronto area in the next few weeks. So at Millennium Square, we have free solar observing on September 13th from noon to 3 p.m. Please come join us down on the Lake Ontario shore to observe some sunspots and whatever else the sun is happening to be doing on that date. Please check our website for a go, no-go decision before heading out. And then coming up the DDO, this Friday, September 5th, from 8:30 to 10:30 p.m. is Constellations Connecting the Dots. Registration fee is as seen here, and you can register online. The links are at rascto.ca. And then Saturday, September 13th, also the DDO, Astronomy Night, Who Really Discovered Neptune, from 8:30 to 10:30 p.m. Again, registration fees are as seen here, and links to register can be found on our website. Saturday, September 20th from 8 to 10 p.m., Spectacular Saturn, the ringed planet at opposition. As Andy mentioned earlier on, every year when orbits line up and Earth and another planet are in a line with the sun, then that's called an opposition. So we're doing a little bit of a shindig. So come join us. Take a look at Saturn through some telescopes. Again, registration fees are as seen here, and links are at rascto.ca. And then we have at Millennium Square our free public star party on September 26th or 27th, depending on the weather, from 6 p.m. to 11 p.m. So join us for an evening of free public stargazing along the North Shore Lake, Ontario, in Millennium Square. We'll be starting out with some solar observing in the evening as the sun sets. And then as the sky gets darker, take a look at the moon, the stars through our telescopes. We'll have some astronomy literature at the info booth. And if you have your own telescope, bring it along and we'll be happy to help you set it up and aim it at the moon. Remember, things are cooler down by the lake, so dress appropriately and check out our website for a go, no-go decision based on the weather before heading out. And then the City Star Party for Baby Village Park for members only is the first clear night of Monday, Tuesday, or Thursday of the week of September 29th. So, and it's the first clear night. So if it's clear Monday night, but it's clear also Tuesday, we're only doing things on Monday. So one night only, whichever is the first clear night. Please check out our website again for a go, no-go decision based on the weather. Our CAO, the Carr Astronomical Observatory, is open. Masking is optional, and please see the CAO bookings page for details before signing up. This is the part where I boost the options of membership. And actually, now that I think about it, I do need to renew. It's that time of year. So you can renew or sign up online if you join us. And if you like what you saw and you want to be a member of the RASC, drop us a line at secure.rask.ca. Gift memberships are also available. Contact the national office at mempub@rask.ca. The Toronto Centre runs on clean, renewable volunteer energy. If you're a Rask Toronto Centre member, if you're interested in helping out and you've got some free time, please let us know. You can contact the volunteer coordination team at volunteer@raskto.ca. The meeting after the meeting, we adjourn to VMV's Bar and Grill, which is just southeast of campus on Keele Street, just south of the university's main entrance. There's free parking. So yeah, when you're done with taking a look at the telescope, if you're so inclined, please come and join us. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us, both here in person and online. Please follow us on all the forms of social media we've got listed here. For those of you watching us live on YouTube, please like, subscribe, hit the notification bell. And as always, be safe and keep looking up. Good night, everybody.